Hi, grade 11s. We are learning about vertex form and quadratic function, which is a very valuable form, and what that can do to help us graph and know things about quadratic functions. Okay, so we have this high school basketball coach brought in Judy, a trainer from one of the local college teams, to talk to players about shot analysis. Now, Judy demonstrated using a stroboscopic photograph, so like a strobe light taking photographs, and she said how shots can be analyzed and represented by quadratic functions. She used the following function to model the shot. Negative 0.1 x minus 8 squared plus 13. In this function, to represent the horizontal distance in feet to the ball from the player, and y represents the vertical height in feet to the ball above the floor. She mentioned that when she has a quadratic equation in this form, she did not need the photograph. She could quickly sketch a graph of the path of the ball just by looking. How could she predict the graph of the quadratic equation would look like? So she just given this equation, she could predict what it looks like. Okay, so what we're going to do now is we're going to go through and see how those values change. So first of all, and you guys can just watch, I'm going to compare everything to y equals x squared, just my regular graph. Couple things. This has a vertex of 0, 0. It has an axis of symmetry where you could cut it in half with x equals 0, the vertical line x equals 0. Okay, so I'm going to go through these steps with you guys. We have y equals x squared. Now what we're going to do is we're going to change the coefficient in front of x. So we're going to see what happens when we put the value 3 there. And I'm showing the changes in this red graph. So how does the red graph compare to the green graph? So when we have 3, oh, my squared is in the wrong place here. Let's see if I can fix that. There we go. So my 3 there, if I change the value of 3 to negative 5, oops, I do still need an equal sign. What happens to the graph? If I change it to negative 7, if I change it to negative 9, if I change it to negative 100, what if I do some fractions? Negative 0.5, negative 0.08. What if I do a positive fraction? 0.009. Okay, so how does the number in front of the brackets, in front of the squared term, affect it? How do the parabolas change? Well, it seems like if it's positive, it's concave up, negative concave down. The more positive it gets, so the bigger the number in front, the more positive, the more narrow. When I get a very small positive number, like 0.09, it's less wide. Okay, and then when I get negative, it is downwards, and the more negative I go, the narrower it gets. So that's how that affects it. B, for each function you graph, determine the coordinates of the vertex and the equation of the axis of symmetry. So for everything that I tried here, what was the vertex? No matter what, my vertex is always at this point right here, which is 0, 0. And no matter which graph I did, my axis of symmetry was always at x equals 0. So it seems like the number we put in front of that squared term does not affect the vertex, and it does not affect the axis of symmetry. C, now what we're doing is we're changing a constant. So we have our x squared, and what we're doing is we're adding different numbers onto the back. So there we have plus 5. Here we have minus 10. Here we have minus 3, minus 5 actually, minus 1.5, plus 0.5, plus 8, plus 3. Okay, so what seems to be happening here? How does it change? It's like there's a vertical shift, either up or down. And the next question says, how does the coordinate of the vertex and the equation of the axis of symmetry? So in this case, case, my vertex is 0, my x value is 0, my y value is 3. Interesting relationship, that y value there. What about my axis of symmetry? It's still x equals 0. Okay, let's try another number, see if that same relationship. If we put -9, where is my vertex? Actually, instead of me writing, let me just point to it. My vertex is at 0 and 9. So that -9 matches with this value, with the value we added to the x squared, or subtracted in this case. And my axis of symmetry is still x equals 0. So it seems like the number that we add on changes the vertex, but doesn't change the axis of symmetry. Okay, looking at D, we have x minus, we're going to get rid of that, x minus 1. So now we're actually putting something into the brackets. And we're looking at how this shifts. It seems like it shifted to the right. So -8, shifting to the right even more. -7, -5. Oops. Let's try adding. +1, +3, +4. Okay, so this seems to do a horizontal shift. And it seems like it shifts the opposite way. Like if we have a +6, it shifts -6 units over. And if we have a -6, they go +6 units over. So the number subtracted or added to the brackets affects our horizontal shift. Now let's look at the vertex here. The vertex in this case is 6, 0, and the axis of symmetry is x equals 6. So this number in the brackets really changes our number, our x coordinate of the vertex, and also our axis of symmetry. Okay, what they ask us to do next in E is they say, and let's go to question E on here, is they say, now we need to make a conjecture how the values of A, so the number in front, the value of H, and the value of K determine the characteristics in a parabola. So I'm looking for axis of symmetry, I'm looking for concave up and down, and I'm looking for vertex. So just to give you an idea, so we're changing HK. If I put the number 2 here, and I'd go +6, oh, let's do a better number, +2, my vertex is at 6 and 2. My axis of symmetry is x equals 6. Let's try something else. Let's do 7. Let's go +7. Oops. +7 and +7 and -5. My vertex is at -7 and 5. My axis of symmetry is x equals -7. So the conjecture that we should make for E is that the vertex is at HK. I'll move up, let's see if we can see this. The vertex is the value of HK. The axis of symmetry is x equals h. The parabola opens upwards and downwards for positive and negative A, and the parabola becomes narrower as A becomes more positive or negative. So anytime we have a quadratic equation in this form, a number, bracket x minus a number, all squared plus k, we can find out a ton of information. Okay, now we're going to test our conjecture by predicting the characteristics of the graph of -0.1x minus 8 squared plus 13. Okay, so first of all, the a value, negative tells us it's going to be downwards. And is it going to be wider or narrower? It's going to be narrower. this is, or sorry, of h. This is our value of k. So our vertex is going to be at 8, 13, and our axis of symmetry is going to be x equals 8. Okay, so these are all the things I predicted using that. And now we're going to use our graphing calculator, and we're going to see if we got that right. Okay, so y equals, oh, this is exciting, negative 0.1. It's going to start graphing some crazy stuff before I finish. X minus 8 bracket plus 13. And I can't even see my graph. I'm very scared. How do I zoom out? Oh, there we go. What did I do wrong? I forgot to square it. That's why it's not working. Show keypad squared. There we go. There's our vertex. Is that concave down? Yes. Is it narrower? Ms. Cantlon made a mistake. It should have been wider. Hopefully you guys yelled at me. Okay, it's concave down. The vertex is at 8 and 13, and the axis of symmetry, if we cut it in half, would be at x equals 8. Perfect. Okay, so this is super powerful information that we have. Okay, let's see here. We're going to sketch the graph of the following function. I don't want you guys to see the answers just yet. F of x equals 2x minus 3 squared minus 4. State the domain and range. Okay, first of all, I can tell right now that it is a concave element. That's positive. And is it narrower or wider? Careful, Ms. Canton makes mistakes here. Narrower. Okay, the vertex is going to be at 3 and 4. And the axis of symmetry is going to be at x equals 3. Negative 4. Sorry, made a mistake there. Okay? So this is tons of information we can know. Before we even graph it, I can actually say the domain and range. You got domain is all the x values. And for all quadratic equations, x is a member of the real numbers. Okay? The domain is down. Range, however, if this is concave up, it looks like this. Y can only be the values bigger than the y value of the vertex. So y is a member of the real numbers, but y must be greater than or equal to, the y value there is negative 4, so I actually should have drawn that. Negative 4. Okay, let's see how we did. So we said it opens upwards, we said that. The vertex is at 3 and negative 4, we got that too. Axis of symmetry, fabulous. So, oh, this is what they did, is they found another point. They put the point, they just subbed in the value 0, so they found a point of 0 and 14. So they just put another point. They mirrored that point, since that's 3 spots away from the axis of symmetry. They could put another point 3 points away there. That's really cool what they did. Yep, it's the same horizontal distance. Cool. Then they made a beautiful graph. Let's look at how we did our domain and range. All x, such as x is a member of the real numbers, we did that. Y is greater than or equal to negative 4. Wow. Fabulous. We are doing great. Okay, I just want to say a couple of things about when you graph for me, what I like to see. I like to see that you have your x and y labeled. I like when you actually draw it out and you say, this is x and that's y. I like to have that. Okay, I like your vertex labels. So you should have some point, and you should write it as, this would be 0 and 2, say. I like your axis of symmetry labeled as well. Okay, so I want to, usually we put like a dashed line, and at the bottom we would say x equals 0. Okay, and I want at least 2 other points. Okay, and it's really easy just to do 1 point, and then mirror it on the other side because it's the same distance apart. And I like to have the coordinates here, whatever they are. Like 5, and 3, -5, and 5. Okay, so at least 2 other points that I like to have. So these are the bare minimums I like for sketch. So if you guys could do these on each of them. Okay, all we have left is a little summary. The vertex form of the equation of a quadratic function is written as follows. Y is equal to a, x minus h squared plus k. The graph of the function can be sketched more easily using this form. Okay, a quadratic function that is written in the vertex form has the following characteristics. The vertex is hk. The equation of the symmetry is x equals h. The parabola opens upwards when a is greater than 0. It has a minimum value of k. So this is going to help you with your range. The parabola opens downwards when a is less than 0 and the function has a maximum. Okay, something I forgot to tell you about. If I had y equals 3x plus 7 squared plus 2. Okay, in this case, h is -7. This is where you're going to make a mistake. Because the form says you're subtracting h, because I have a positive there, that's the same as saying y equals 3x minus -7 squared minus 2. Okay, so this is going to be an error you make. So the vertex in this case is 7, -2. The axis of symmetry is x equals 7. Okay, and you always have your graphic calculator handy to check these as well, but that's an important point. Okay, a parabola could have 0, 1, or 2x intercepts depending on the location of the vertex and the direction in which the parabola opens. Okay, so if my vertex is down below and it opens up, I'm going to cross it twice. Similarly, if I had a vertex concave down and it was above, I would have 2. Okay, I might have 1 x-intercept if my vertex is on my x-axis. So in other words, if the y-coordinate is 0. Okay, and then I could have no x-intercepts if it's a concave up and my vertex is above the x-axis. Similarly, if I had concave down and my vertex was below, I could have no x-intercepts. So this is just another concept that's going to come up later. Okay, you guys have your assignment sheet, so you can start your assignment.